Okay. So here thermodynamics. So what this chapter deals with, what it explains us. Okay. See, during the chemical reactions, there might be heat absorbed or heat might be released. The heat changes associated during a chemical reaction can be discussed under this chapter. Okay. So now see here, the study of flow of heat or any type of energy into or out of a system during a chemical or physical transformation is called thermodynamics. Okay. Now the same chapter you will be seeing in physics also. So but here we will be more into the chemical thermodynamics. It means chemical reactions and associated energy changes. Okay. Right. So here it only deals with, see here, so what it exactly deals with, feasibility of a chemical reactions. It means spontaneity, feasibility. What are these terms here? See, there are some processes in the nature that happens naturally. If a process is taking place naturally, you can say that as a spontaneous process or spontaneous reaction. Okay. So now the thermodynamics says about, or it predicts the spontaneity or a feasibility of a particular reaction, whether a chemical reaction takes place or not. Next, for a feasible reaction, if a particular chemical reaction is possible, then how much amount of heat energy associated with that process can be given from thermodynamics. Okay. Now thermodynamics cannot explain how fast a chemical reaction is taking place or how slow a chemical reaction is taking place. What it explains? The heat associated during a chemical or physical change, but not how fast it is taking place or how slow. So this how fast, how slow, this is comes under rate of a reaction. So where we will discuss this rate of a reaction in chemical kinetics. We have separate chapter for that. What is that? Chemical kinetics. Okay. So here heat changes, there how slow, how fast a chemical reaction is taking place will be discussed in chemical kinetics. Okay. Right. So now before entering into the chapter, you need to know some very basic concepts, basic terminology that we are going to use. Okay. I hope you are much familiar with these terms. See, basically there are three terms. Okay. See, one is called system, next surrounding, and the next boundary. See, for example, we are doing a chemical reaction. Okay. Let us say we are doing a chemical reaction in this container. Okay. So now this container in which we are doing the chemical reaction, which is under our observation, is considered to be system. Okay. The remaining portion here is considered to be surroundings. Now there is a small area or the boundary, or I can say something is separating this system and surrounding right now. So that is called, so this boundary can be an imaginary one or it can be real one. See, if I say this is a beaker or a container, see this is a real boundary here you can observe. It's like physically it is like separating boundary, surroundings and as well as system. But here there is like open one. So I am considering this area might be the boundary here. So boundary can be real one or it can be imaginary. Okay. So now these systems are of different types again: open system, closed system, isolated system. So what do we mean by open system? See, during a chemical reactions, what are the things possible to exchange between system and surroundings?
Matter.
See, here some chemical reaction is taking place, means that is something like matter only now. Between like that matter only, like some transformation is happening in the matter itself. So this exchange between system and surroundings, if the matter is exchanging between system and surroundings, then we can say it as a open system. Along with the matter, heat also exchanged, because it is open means heat comes out. So both heat as well as matter exchange takes place in open system. Now closed system means, so matter cannot come out but heat may come out. Okay. So only heat can be exchanged between system and surroundings. Next, here if there is no exchange of heat and matter between system and surroundings, we can call it as isolated system. Okay. So the third one is what? Isolated system. In isolated system there is no exchange of heat and matter between system and surrounding. I hope you know these very basic terms first. Okay. Right. So here I will tell you give one example for open system. like a cup of tea placed on a table. Now tell me, with a cup will be open system only now, so matter can be comes out as well as heat also comes out. Next one, a bottle of water with capped one, closed system. Okay, next, what about this isolated system? See, thermoflask almost nearly act as isolated, but not exactly, but nearly, because thermoflask acts up to or resist up to some 5-6 hours only. After that it loses its capacity or its efficiency, and whatever the heat is there, that will be also gets cooled down right now. So thermoflask almost considered to be isolated system. Next one, yeah, done with this. Okay, so when I say heat, what I am saying? Heat. So heat is indicated with symbol Q. So now something called work indicated with W. Okay, so let us move forward little. Not depend. See, for example, there is a change taking place from here to here. From 1 to 2, there is some physical process or some process is happening. Some change is taking place. Okay, so now whether the change from 1 to 2 happening depends only on initial and final states. How, like final states only, not how this final state is coming from initial one. So this kind of process or this kind of properties are called state functions. Like what are the state functions, they will ask you. For example, here pressure, temperature, volume, okay, and entropy, internal energy change, enthalpy, all these terms comes under what? State functions. Okay, so now for example, your like one more term is called path function. What is this path function means? Slowly he is walking. Okay, so now who will spend more amount of energy here? Tell me. First person, because he is running, so therefore more amount of energy is consumed or more amount of work is done by this. Okay, so now if you see it, depending upon what is the way you are doing that process, that's why I can say heat is a path function. So what is the way he is following, depending on that is defining his amount of heat released or absorbed. Okay, the work done by that fellow. Okay, so who is doing more work here? First person, or amount of heat released from the first person will be more. Okay, so this is what the path function means. Otherwise, one more simple example. See, you are at the 4th floor. Okay, so now you are directly going to the ground floor like this, like exactly like this. Might be using a lift or some separate hole or something like that. And another fellow taking the same luggage and going from here to there to there from the steps. So now who will be consuming more amount of energy? The one who is going to the steps now. So now path is defining his amount of heat released or work done. Okay, so that's why what are the two examples for path functions? I can say work and heat. What are the two examples for path function? Work and heat. You just remember these terms. Okay, so now that's it. These definitions are done. Next, thermodynamic properties are there. What I am saying next one? Thermodynamic properties. So thermodynamic properties means like there are two types. One is intensive, another one is extensive. So how can we identify them? So intensive properties are mass independent. What I am saying? Mass independent. So what are the two terms I am saying? One is intensive, extensive. So like quantity independent. Quantity means like some amount or mass. Mass independent properties are called, see, intensive independent. What I am saying? Intensive independent. Okay, I will tell you how to understand that term. You just remember intensive, mass independent or quantity independent. Next, extensive, mass or quantity dependent. So how can you understand these? For example, I have a box here. What I have? I have a box. So now in this box, some matter is there. Okay, some matter is there. Let us say like 2 liters of water is there in this box. How much? So now if I divide this box into 2 equal halves, what I am doing? I am separating that box into 2 equal halves. Okay, so now is there any change in the temperature from box 1 to box 2, like 2 boxes, or they will be same as the before? I am giving you this box with 2 liters of water at this room temperature. Now I am dividing this box into 2 equal halves at this room temperature only. So now I am giving you a thermometer to check the heat or temperature, the box 1, box 2 after separation, or is there any change? Same as before, no? So is it depending on mass? Temperature is depending on mass? No, no. Whatever you have seen the initial case, now also being same. So it means, can I say temperature is mass independent? Otherwise, you just take. I am giving you one glass of water and you have checked the temperature. It will be having some specific temperature now. Now, I have given some 10 drops of water droplets here. So now again you are checking the temperature for the droplets. Will it be any change here? So whatever the quantity you are taking, the temperature will be remains same right now. So can I say temperature is mass independent? So that can be comes under. So like this you can understand the terms intensive and extensive. Next one, if what is the initial volume I have given? 2 liters. 2 liters. Now you are dividing into 2 equal halves. What happens to the volume? Volume becomes like 1 liter, na 2 liter box I have given, you are cutting into equal halves, means 1 liter, 1 liter. So now quantity is changing or not? So I can say volume is a quantity dependent. Yes or no? Okay. So that comes here under extensive property. Okay. Similarly, I am giving you, I have 10 tomatoes. How many tomatoes? 10. So these 10 tomatoes weighs 1 kg. How much? So now what I am doing is, I am giving you now 5 kgs only, 5 tomatoes only. Now what is the weight of that approximately? Half kg. See, if I decrease the quantity, what happening to the weight? So can I say weight is also mass dependent? So weight is also mass dependent. So it is extensive or intensive? So is this clear how to identify? Mass, weight comes under extensive. So here you can simply say it as amount of substance. Amount of substance is what? Intensive or extensive? Okay. So amount of substance also can be said as number of moles also. Number of moles also is an extensive property. So like this we have different intensive and extensive properties. Just to go through this. These are some examples. See, I am saying viscosity of a liquid. See, viscosity, you have studied viscosity in the physics, right? Viscosity of a liquid will be specific value, it will be fixed right now. Viscosity of oil will be some specific value, viscosity of water will be specific value, will be there. These are fixed, it doesn't depends on quantity of substance. So can I say it extensive or intensive? So that's why it is intensive. See, freezing point of water I am saying 0 degrees you will say. You won't say like for 100 ml of water 0 degrees, 200 ml of water minus 2 degrees. You won't say like that right now. Just you will say freezing point of water or melting point of water is this particular value. It means all these are what? Quantity independent properties. So these are considered to be intensive. Everyone clear with this? How to identify intensive and extensive properties? Yeah. So take the list of these things. Okay, and one more relation you should remember, intensive properties, intensive, the ratio of to extensive, ratio of to extensive properties is one intensive property. For example, mass is extensive or intensive? Volume, extensive. So mass by volume is what? Mass by volume, density. So now this density is intensive. Okay? Like density of water if I ask. 1 gram per ml you will be saying like this. Density of water, it is fixed only now for a particular substance, so it is an intensive. Okay, done. So write all these examples. So if you go to the PYQs, there will be direct question from which are the following is are extensive and which are the following are intensive. Like this you will see the question. Temperature, pressure, density, next concentration, molar heat capacity. If you see a term like this, see heat capacity is extensive. What I am saying, heat capacity is extensive, but molar heat capacity is see why I am saying like that. Heat capacity is moles is molar like heat capacity extensive I am saying. Number of moles also extensive. So ratio of to extensive. So if you see like molar heat capacity, molar volume, volume is extensive, but if I say molar volume, intensive. So I will give you a list for extensive also, but have you written these examples? Yes. Next, this one. Take the list of extensive properties also. Don't write all these big definitions. That single line definition you can write. These examples you can write. Next one. First what we have studied, like state function, path functions. The next, thermodynamic properties. We have two types, intensive, extensive. Now thermodynamic processes. What is that next? Thermodynamic processes. Okay, like thermodynamic processes. Okay, so first one is like isothermal. Isothermal process means what? So that process is happening at iso means same, thermal means heat. At same temperature if the process is happening, then we can say isothermal process. So same temperature means temperature is being constant. What is constant here? Temperature is constant. See, if you do constant, derivation of any constant will be 0. How much? Derivation of any constant will be 0. So during this process, dt can be considered to be 0. Okay. So now PV equals to nRT. What is this? Ideal gas equation. For 1 mole you can say PV equals to RT, like this you can write. So what is constant here? T is constant means R is also constant, a universal gas constant we'll say. So both of them are constants here. So I can say P is equals to RT by V. How they related now? P, V. How they related? Inversely. So this is how you will see the graphs. Inversely relation. Okay. So now when the graphs are drawn at constant temperature are called isotherms. What is that graphs called? Isotherms. Okay. The next one. See at this particular, see this process is taking place at what? Constant temperature. Now I am saying this process is taking place at temperature T1. At what I am saying? At temperature T1. And one more process is taking place at temperature T2. What I am saying? Two graphs I have given. One is temperature T1 and temperature T2. Now I am saying which is at higher temperature? Which is greater, T1 or T2? The one which is above will be greater here. Okay. So how can we identify? See PV relation. See for a particular pressure, for a particular value of pressure and volume. See this is at higher, like just take like this. So which is at the top is considered to be greater. T2 is greater than T1. Like this you can understand. Okay. So the next one is, what is the next process we can say? Isothermal means temperature constant. Isochoric. Isochoric. It means which is constant here? Volume is constant. What is constant here? Volume is constant. So change in volume will be considered to be 0. If we draw any graphs like this, those graphs are called isochores. What is that? Isochores. The next process is isobaric. Isobaric means what is constant? P constant. So change in pressure will be 0. So at constant pressure if we draw any graphs, that graphs are called isobars. Okay. Now we will be moving forward with basic laws here. Okay, the graphs are, if anything required, we'll do while doing the numericals. Okay, so what is this basic one, like zeroth law? What this zeroth law says? Once read that lines. It states that if a body A is in thermal equilibrium with body B, okay, and body B is in thermal equilibrium with C, then A, B, C are must be in, all of them are in thermal equilibrium. It means it's very simple. See, I am taking a okay. See, here I am taking like 3 rooms, let us say, or 3 systems I am saying. So A and C are in thermal equilibrium. What do we mean by thermal equilibrium? The temperature in C and temperature in A are equal. Similarly, here and here are in thermal equilibrium. Which one? B and C. TB is equals to TC. But what about AB? They are not in like thermal equilibrium here if you observe like this. But they are in this way, if you see, they are in thermal equilibrium now. So from this one 1 and from this one 2, what you can say? From 1 and 2, TA is equals to TC, which is equals to, so TA equals to TB equals to TC. So this is very basic law, but it is proposed after giving the first law of thermodynamics. That's why it is named as zeroth law. Okay, this is what you generally observe. Okay, so the next one is first law of thermodynamics. What is this first law of thermodynamics says? Once tell me. Neither be created nor be destroyed, but it can be converted from one form to another form. Okay, so it means, once again read that, it can be converted from one form to another form, but we cannot create or destroy. So the total energy of the universe, what I am saying, total energy of the universe remains constant. See, we have studied about system and one more is surroundings right now. So system plus surroundings together called as universe. What is that? So universe includes everything. Okay, it means system has some energy, surroundings has some energy, Maybe energy can be transformed from system to surroundings or surroundings to system, but overall energy of the universe will remains constant. The total energy remains constant. Once read, the total energy of the universe remains constant. Okay, so which is expressed as a sum of energies of system and surroundings. So energy of universe is equals to energy of system plus energy of surroundings. Energy can transform from surrounding to system, system to surrounding, but total energy will be universe energy will be remains constant. Okay, so this is what the first law of thermodynamics. Now mathematical form of first law of thermodynamics is an important thing you need to remember. See, if you say any matter, what I am saying, anything you take, let us say this is a system. This is a system having internal energy U1. What is its internal energy? U1. So now you are supplying some Q amount of heat. What you are doing? So now what happens? Its internal energy U1. You are supplying some Q amount of heat. So its energy become Q1 plus U plus Q. Okay, and you are doing some work on this. What you are doing? Work on this. Then its internal energy becomes U2. So now what is U2 means? U2 is equals to Q1 U1 plus Q plus W. Okay, then if I want to write U2 minus U1 equals to Q plus W. So this change is there now, U2 minus U1, that is called internal energy change. So this is what the final equation you need to remember. So what is the first law of thermodynamics? Mathematical form, du equals to Q plus W. So we can also write for small changes du equals to dQ plus dW. Okay, so what is this? Du indicates change, dQ indicates change in heat. Okay, dW indicates change in work done. So now using this we need to solve some questions. Okay, directly from this we can expect some questions. I will give you. But before that you need to know what is this dW and dQ here properly. See, if this is a system, up to here first law is over. Okay, so if this is a system, if you are supplying some amount of heat to the system, what I am saying, you are supplying energy into the, so that should be indicated with symbol positive. See, if you are adding energy to the system now, what is the symbol you need to use? So plus Q. Okay, now if energy is released from the system, minus Q. So minus Q indicates what? Heat, release of energy you can say. Or other ways, you are doing some work on the system. What you are doing? So it should be plus or minus? Plus W. Okay, if system only doing some work on the surroundings, minus W. So this is heat absorbed by the system. This is heat released by the system. You need to understand this very basic term, then only you can do the questions properly. So what about this? Work done by the system. What about the above one? Okay. So now when we are using this formula, you need to understand the question whether they are saying heat released or heat absorbed, or work done by the system or work done on the system. Based on that you need to use these signs. Okay, we will see the question, then you will get more clarity. Done up to here? Okay, read this question once. Read it properly and tell me what they are saying. A system does 100 joules of work on surroundings. So work done by the system on the surroundings. Right now, see, a system does 100 joules of work on the surroundings. Okay, it is work done by the system or work done on the system? by the system on the surroundings. See, heat, the system does 100 joules of work on surroundings by absorbing 150 joules of heat. Calculate the change in internal energy. So, what is the formula? du is equals to dq plus dw. So, now tell me dq is positive or negative here. So, this is main absorbed, it means plus 150 joules. This dw minus 100. So, plus 150 minus 100 plus 50 joules. Okay, there will be plus and minus also sometimes. Based on the understanding, you should say it is 2. Is this clear, everyone? Yeah. Next one. Okay. We'll go to this question. Before that, say I told you something about state function, no? State function I told you. Okay. So what are the terms you should remember for state functions? P, V, T, and something called entropy is there. Okay. H, enthalpy will be there. Gibbs free energy will be there. Internal energy is there. All these are what? Examples for S, like you just remember it, it like this. I will tell you one simple way to remember. S, P, V, T. What is this? S, P, V, T, H, G, A, U. All terms comes here. S means entropy, P means, V means, T, H, enthalpy. Heat should be indicated with symbol Q. Okay. So this is a path function. Q is a path function. So H is enthalpy. I will tell you what is that. G means Gibbs free energy. A means Helmholtz energy, that is not there. You just write it. Next one is what? Internal energy. Okay. These are the things are state functions. Okay. So if a state function is operating in cyclic process, what I am saying? Cyclic process. What do we mean by cyclic process? Yeah, it should be like a closed loop. Like it can be in this manner also. See, 1 to 2, 2 to 3, 3 to 4, again 4 to 1. So it is in a closed loop now. Can I say this is a cyclic process? This is also cyclic process. So if any of the state functions are operating in the cyclic process, then change in that state function will be 0. So state function I am indicating with symbol Z. So dz, if it is operating in the cyclic process, then total change will be 0. So what is this indicates here? Circle, like closed cyclic, like cyclic process it is. Okay. If it is operating in the cyclic process, the state function change will be 0. So a system operating in cyclic process, the enthalpy change will be 0. Entropy change will be, temperature change will be, okay, like this. Okay. Now one more thing. There is one term called internal energy. What I am saying? Internal energy. I hope you are studied this, but I will tell you once again. U and E. What is the symbols for this? U and E. Okay. So now internal energy means if you take any substance, if it is existing in the nature, means it might be associated with some energy internally. Okay, it has some energy internally. So how that energy is associated there? So every particle associates with something called kinetic energy and potential energy, or I can say, see if you are taking water molecule like this, okay. So this hydrogen, oxygen, what they have? Bond is there now. So but that bond contains some energy. That energy is called bond energy. Okay. Now this molecule, these bonds keep on vibrating. So that is called vibrational energy. Okay. There is also called as translational energy. Like this, very small microscopic energies will be there. Sum of all those energy considered to be so internal energy means what? Sum of all the possible energies associated with a system is considered to be internal energy. Okay, U. Okay. Now exact value of this internal energy cannot be calculated. Why cannot be calculated? See, these are very microscopic energy levels. with very little change, that values keep on changing. So that's why it is very difficult to calculate exact value of internal energy. That's why in thermodynamics we will only calculate change in internal energy. What is change means? U2 minus U1, like that. Okay. So now tell me, internal energy state function or path function? State function. Internal energy is extensive property or intensive property? Internal energy, extensive property. What I am saying? Extensive properties. See, what are the extensive properties once again? Amount of substance, mass, volume, number of moles, heat capacity, internal energy, enthalpy, Gibbs free energy, entropy, number of moles, that is nothing but amount of substance. Next, Gibbs free energy, Helmholtz energy. Next, see, when I say free energies, that comes under extensive properties. Like Gibbs free energy I am saying, Helmholtz free energy I am saying, that comes under extensive. Next one, enthalpy, internal energy, extensive. Okay, right. These are the things you need to remember. So you can write here, it is a state function and it is an extensive property, and exact value of internal energy cannot be calculated. Okay. So now what is the first law of thermodynamics? Once again, mathematical form. du equals to dq plus dw. Okay. So now this one, see, first one, you need to understand change in internal energy once again. So what it is, what I told you, the sum of all types of possible energy associated with the system is called internal energy. Now once again I am saying one more definition, heat content of the system measured at constant volume is called internal energy. See what I told you, sum of all types of possible energies associated with the system is called internal energy. That is nothing but, possible energy is nothing but here heat content of the system that is measured at a constant volume is called as energy. Okay. So here you can see at a constant temperature. What is constant here? When temperature is constant, how this first law of thermodynamics changes? When you are putting temperature as constant term, what happens is internal energy directly proportional to temperature. It means internal energy changes with change in temperature. But what is constant here? If temperature is constant, then change in temperature will be 0. If this is constant, the proportionality factor, it means U also constant, then change in U will becomes 0. So this term is becoming 0. Then what you can write? dq plus dw is equals to 0. So now dw equals to minus dq. So at this is at which condition? So at isothermal condition, can we say dw equals to minus dq? Constant temperature means what? Isothermal process only, no? If isothermal process, so what happens to first law of thermodynamics, they will ask. du becomes 0, then dq equals to minus dw, or dw equals to minus dq. Okay. Similarly, here what is the one more term we are seeing? Work done. So how you will give work done? See, this is nothing but force into displacement. What is that? Force into displacement. So now force, like force per unit area is what? Pressure. Force per unit area is what? Pressure. So in the place of force, I can write pressure into area. So pressure into area into dl. What is this dl? Displacement. See, what is mean by volume? Length into breadth into height. If I do only L into B, this is called area. If I also multiply with H, volume. See, this is area multiplied with DL, volume. But here there is change now, so I should write it as change in volume. So PdV, so work done will be equals to PdV. What is the formula of work done? PdV. So when it comes to chemistry, we will be using a sign here, dW equals to minus PdV. So what is this minus indicates here? Work done by the system. What is this minus indicates here? Work done by the system. So this is a final formula you should remember for work done. Okay. So now dV means what? Again, dV means what? Change in volume, like V2 minus V1. Okay. So when you are doing the numericals, it will be useful. You just write this as it is. Okay. So try to answer me this question once, the last question first. Are you able to see from last? If not, I will read. The question says, a system is provided 50 joules of heat and work done on the system is 10. The change in internal energy is, how you are doing, tell me? A system is provided 50 joules of heat. System is provided, it means to that system heat is provided. How much amount of heat? So it is heat given to the system or released by the system? Given to the system. So dq equals to plus 50. You just make it like this first. Understand the question properly, otherwise simple calculation goes wrong. Next one, work done. So dW is negative or positive? No. I mean work done on the system, it means positive 10 joules. So from this du equals to dq plus dw. So whatever the signs you got, you put here. 50 plus 10, 60 joules. This is your answer. Okay, done. It is easy. First law of thermodynamics questions are easy. Next one. See here what they are saying. Question says dE equals to 0 for which process they are saying. dE means what? Change in internal energy. So when it is 0 they are asking for a cyclic process. Perfect. Next one, next term also I am adding. 1, 2, 3, 4 options are there now. Fifth option also I am adding during isothermal process. Will it be correct or not? Why isothermal process du equals to 0? Temperature is constant. Internal energy is proportional to temperature. If temperature is constant, so change will be 0. Okay. So fifth and first one is perfect. Remaining are incorrect. Okay. Next one, if you go through this question, out of the following, are you able to see? Out of the following, the correct statement is. Out of the following, the correct statement is. W is a, what is this? Work is a path function. Next, dE equals to Q they are saying for isobaric process. So how can we get this exactly? Whether this process, whether this statement is correct or not, how can we say? From first law of thermodynamics, like what is that? du equals to dq plus dw. So in the place of dw I can write minus p dv. So du equals to dq plus du equals to dq plus p dv I can write. Isobaric process means what is constant? So if this is constant, there is no change, that will be remains constant only. It means definitely du must be equals to dq plus minus pdv, like dq plus dw only. It means this statement is wrong. If I say isochoric process, isochoric means what is constant? If V is constant, then change in V will be, if a particular term is constant, then change will be, so dV becomes now 0. So this term becomes 0. If this is 0, something into 0, so this term completely becomes, so du equals to dq at constant volume. So during isochoric process, dq equals to what? So now see this one, q equals to 0 for every cyclic process. Is that statement is correct? No. Why it is not correct? Q is not a state function, it is a path function. If it is a state function, definitely in cyclic process it is equals to 0, but for path function we cannot say like that. Okay, so it is incorrect. Next one. So dE equals to 0 for every cyclic process. This is correct because it is a path state function. Okay, so first one is incorrect, third one incorrect, second one incorrect, fourth one is the only one which is correct. Okay, so now one more time tell me what is the internal energy definition I given you, the second one. Heat content of the system measured at constant volume is called, see, heat content of the system measured at is called, see, heat dqv, heat content of the system measured at constant volume is equals to internal energy. Whatever the statement you have written, it is observed here. At constant volume, if you measure the heat, whatever the value you will get, that is nothing but its internal energy. So you can write this under that whatever the lines you have written. Okay. Done with this? Next. Yeah, try to answer these questions also, I mean these statements. Okay. So to answer this, you need to have a little more idea. Let me give you that. Okay. See, there is one more term called enthalpy. What is that? Enthalpy. Okay. So now initially what we have studied previously? U. What is that? U means internal energy. So internal energy is in internal energy. What is the final conclusion we got? Change in heat content of the system measured at constant volume. Similarly, change in heat or the heat content measured at constant pressure is called enthalpy. What is that? So change in heat at constant volume is called? Change in heat at constant pressure is called enthalpy. Okay, so now what is the relation between enthalpy and internal energy? So H is equals to U minus PV. What is that? H equals to U minus PV. So again, enthalpy also state function, enthalpy also extensive property. The exact value of enthalpy cannot be calculated. Why? See, again, enthalpy includes what? U plus, this is U plus, okay. So what is this again? Enthalpy means U plus PV. See, if you are unable to calculate U, how can you calculate exact value of H? We do not have exact value of U, so how can we calculate H? Therefore, exact value of H also cannot be calculated. So now here you just derivate this dH equals to du plus PdV. Okay, so what is constant here? Pressure. See, if I want to derivate this UV formula, if you upload use here, PdV plus VdP you will get. But what is constant? Pressure. If change in pressure is constant, change in pressure will be 0. So this second term becomes 0. So you can simply use dH equals to du plus, this is the final relation for enthalpy and internal energy. Enthalpy and internal energy. See, you know ideal gas, once again tell me PV equals to like RT for 1 mole I am saying. Okay, so just apply derivation on both sides. It becomes PdV is equals to R is a constant, then it becomes dt like this. So dH du plus P d. See, I can use delta symbol or I can use d symbol also for derivation purpose. Okay, up to here it is clear. R dt means okay. So now just divide complete equation with the t dt. dH by dt equals to du by dt is equals to R plus R by dt by dt is 1. So can I write like this? Yeah. So you are going to get dH by dt minus du by dt is equals to R. Okay. So what is this? So dH by dt means this is called Cp. What is that? Cp. Du by dt is called Cv. So Cp minus Cv equals to R. I think you have did this in your first year. Cp minus Cv equals to R. Okay. So what is the Cp Cv called? Heat capacities, like at constant pressure, at constant volume. Okay, this is for 1 mole. For n moles, Cp minus Cv equals to Nr you can write. This is for n moles. Okay, next one more thing. dH equals to, what is the formula we got, that final important one? du plus Pdv. Okay. Pv equals to RT you are writing. From these, for n moles it is nRT. So this equation is valid for what? Only for ideal gases only, right? So it must be gases only. See, in the place of this PdV, I am writing dH equals to du plus nRT. This d as it is I am writing over here. Like if you want, you can take like this also. So dH equals to du plus dn. This equation is for what? So I am writing this is gas, just for indication purpose, into RT. So at a particular temperature, what I am saying, at a particular temperature. If I say particular temperature, temperature is fixed. So temperature is constant only now. So temperature constant, R constant. So what is the variable here? We have only number of moles. That is indicated with delta Ng. So I am writing this dH equals to du plus delta Ng RT. Okay, you can write in this way. dH equals to du plus delta Ng RT. So what is this equation saying, sir? Means, for example, I am writing this ammonia formation equation. N2 plus H2 gives rise to 2NH3. See, all of these are gases only now. All of these are gases only now. So, but equation is balanced? No, it is. So now what is this delta Ng indicates? Change in number of moles. Change means what? Final minus initial. So product side, how many gaseous moles are there? So summation of number of gaseous products minus summation of gaseous reactants. So tell me here how many are there? 2 minus 1 plus 3. So this will be, so delta Ng. Now the relation between delta H and delta U they will ask. How can you write this? Delta H is equals to delta U plus delta Ng. What is delta Ng we got? Minus 2 RT. Okay, finally delta H is equals to delta U minus RT. Like this we can write. Okay, now you will see some questions on this, I will show you. But before that, you tell me what is the relation for H2 plus Cl2 gives rise to 2HCl. Gas, gas, gas. So what is delta H and delta U relation for this, tell me? So all of these are gases only now. Okay, see if these physical states are not mentioned, consider it as the temperature is also not mentioned, means consider it room temperature, like 25 degrees Celsius. Okay, So at 25 degrees Celsius, H2 will be gas, Cl2 also gas, HCl also gas. Okay, so now tell me what is delta Ng first? 2 minus 2, it will be 0. So delta H equals to delta U plus delta Ng RT. Delta Ng is how much? So 0 into something is 0. So delta H equals to delta U. Okay, now based on this, you should answer me this question. The second one you answer me first. Second one. The difference between delta H and delta U when the combustion of 1 mole of heptane is carried out at T temperature. Heptane means, first write the formula of heptane. C7, what is the formula? CnH2n plus 2, C7, 12 plus 2, H14 plus 2, H16, okay, with O2. Next, CO2 plus H2. Like this you should write, okay. Next, what you can do? Liquid they have mentioned. So this is gas, this is gas, this is liquid you can take. Okay. So now, sir, how can we do this? Yeah, you can do this first. Balance the equation like 7, this one, and how many water molecules are formed, how many oxygens are used. Okay. From that, what you need to calculate first? After finding delta Ng, delta H equals to delta U plus delta Ng RT. So find that, put here, you will get the answer from 4 options. Okay, you got how we are doing this? Okay, if you want, I will give you one more simple example. See, I am giving you methane. Combustion of methane produces what? CO2 plus H2. See, if this reaction is mentioned at 25 degrees Celsius, what I am saying? At 25 degrees Celsius, what is the physical state of water? 25 degrees Celsius liquid, physical state of water will be liquid. So it should be liquid. It should be gas. This one, gas. This one, gas. Now delta H, delta U plus delta Ng RT. So now find delta Ng for this. Balance the equation first. That's it now? So now tell me delta H, delta U plus this one, delta Ng is how much? See, should I consider this or not? What is the number of gaseous products? Number of gaseous reactants. See, is this a gas? No, so you should not consider this, only this one. How many are there? 1. Minus reactants are how many? This is gas, this is also gas, so take it 3. So it will be minus 2. So delta H minus delta U is equals to delta Ng RT. So what is delta Ng value you got? Minus 2 RT. Okay. So like this you need to calculate. Okay. Next one, the same question, if they ask it 100 degrees Celsius, what is your answer? Or somehow 105 degrees Celsius, what is your answer? So the liquid converts into vapors like gases. So this should be also in terms of gas. So your answer changes there. So at this value, H2O is in vapor phase or gaseous phase. So now tell me what is your delta Ng here? 2 plus 1, 3 minus 3. So this is 0. If this is 0, delta H becomes equals to delta U. You got the difference what I am saying here? Changes. It means they depends on their physical states. Okay. So at 25 degrees if they say consider water as a liquid. 100 degrees or more than 100 if they say consider water as a gas. Okay. So now sir, what to consider here? See, heptane in the liquid form they are saying. Definitely if heptane is staying in the liquid form means water also stays liquid. Okay. So don't consider now water, consider other things and do this. Okay, will you try now? Otherwise, balance that equation and you will get the answer. Okay, you just write the question and you can try. We'll give you some other topics to discuss. Okay, try to answer me this now. What they are saying? Enthalpy change for the reaction is minus 92.38. Then what is the internal energy change? How to do this? Delta H is equals to delta U plus delta Ng RT. Okay. Next, they are asking about this. Okay. They are asking about this. So what I can write, delta U equals to delta H minus delta Ng RT. Next, what about delta H value they mentioned? Minus 92.38 kilojoules. Minus, what about delta Ng you got for this equation? See, N2 plus 3H2 gives rise to 2NH3, all of them are gases. Then delta Ng is how much? 2 minus 4 minus, so here I can should take here it's minus 2. Up to here it is clear. Next, what about R value? Here we have see kilojoules now it is, so R can be taken as 8.314. This is joule per second per Kelvin per mole, but they are saying kilojoules means 8.314 into 10 power minus 3 kilojoule per Kelvin per mole you should take. Here in kilojoules it is mentioned, so your R value should also be in, this value also should be in kilojoules. So how much I should take? 8.314 into 10 power minus 3 kilojoules per Kelvin per mole multiplied with, what is this? Temperature. Temperature mentioned as 298 Kelvin. So Kelvin, Kelvin, mole, mole, everything is cancelled. Yeah. So if you simplify this, see how can I simplify easily? So 10 power minus 3 is there. 1 by 1000 now, 10 power minus 3 means. So I can simply write 298 divided by 1000 it is. Like this now. So this is nothing but I can simply put 0.298. Can I write it as simply as 0.3 for simplification purpose? Yeah. So 2 into 8.3, how much? 6, 16. Next, 0.3 means 18, 1, 18, 9, 1, 3, 4. 4.98 we got. Okay. So around, this is around and symbol is minus. So minus 92.38 minus of minus plus 5. Units are kilojoules. So what is the final answer? 92 minus 5? 87. So what is the symbol here we have? Minus 87.38. So just check the options. No options? Yeah, but you got the answer now. How to calculate and all. Is this clear or not? So all these simplification steps, it is mandatory for physical. You should habituate to that. So but what are the steps here we need to follow? Tell me once again. See, the enthalpy change is given. Find internal energy change. Use the equation. Sometimes internal energy given, enthalpy will be asked. For both of them you can use the same equation. Okay, if you want you can write fast. Done? Okay. Okay, just answer me this one simple question first. Let me check. Read this first question. For a combustion reaction, which are the following will be true? Out of 4 options. What to consider? What is the relation we have? Delta H equals to delta U plus delta Ng RT. So find, what to find? Delta Ng, how much? This is solid now? 0. Here 1, 2 solids don't consider. This is 1. So minus 1 we got delta Ng. So what is the relation finally? Delta H is equals to delta U or delta E minus RT. Okay. So which is greater out of these two? H or E? See, removing from delta E something, you will get delta H. Means definitely this is less. Something like if delta E is 5, you are removing 2, therefore you will get 3. That is for delta H. So definitely delta H is less than delta E. Like this you should answer. Is it difficult? No. Okay. So after the class, see, after okay, next. Okay, answer me this question. Once read that. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from initial volume of 1 liter to 10 liters. Then change in internal energy. Be conscious. First ఒకసారి క్లియర్గా చదవండి, మీకు ఆన్సర్ వస్తుంది. What they are asking? Internal energy. What is the condition mentioned? So in isothermal process, if temperature constant, U also constant, then change in U will be, so internal energy change will be. So it is very important to understand the question what they are asking. See, what is Q? Heat. So if you supply heat to the system, what happens to its temperature? Increases. So the change in temperature depends on heat. So Q is directly proportional to delta T I am writing. Okay. So now from here, Q is equals to C D T. So I am removing proportionality, I am placing a constant C. Okay. Now C is equals to Q by dt I can write. So what is this C called? Heat capacity. What is that? Heat capacity. Okay. Next one. See, for some amount of substance, like let us say m amount of substance we have, then what happens? This Q equals to mc dt it becomes. Okay. Now C equals to Q by m dt it becomes. So if m is equals to 1 gram, what I am saying, m equals to 1 gram, that heat capacity is called as a specific heat capacity. What is that? Specific heat capacity. If that m is equals to 1 mole, what I am saying, m is equals to 1 mole, you should call it as molar heat capacity. What is that? Molar heat capacity. Now they will ask you what are the units for heat capacity, specific heat capacity, molar heat capacity. Tell me. See, heat means you can say in joules or Kelvin. Okay, let us say in calories. Calorie. Here m mass. So m mass means it will be in grams. Change in temperature means Kelvin or degree Celsius. So for the specific heat capacity, calorie per gram per Kelvin or calorie per gram per degree Celsius. Like this the unit will be written. So now what about molar heat capacity units? Same, calorie. In the place of grams we have mole, per mole per Kelvin or per Celsius. Like this you need to write the units for specific heat capacity and molar heat capacity. Okay. Next one. See, if the molar heat capacity, this one, Cm, if measured at constant volume, what is that? Molar heat capacity measured at constant volume is nothing but dQV by dt we have got. So this dQV means what I told you, internal energy change. So now from here du equals to, what is the formula we will get? Just send that this side, Cv dt, Cv dt. Okay. Similarly, if molar heat capacity measured at constant pressure, at what? Constant pressure. So you should write it as dQp by dt. Okay, dt. See, molar heat capacity measured at constant volume is called internal energy we have written. Molar heat capacity measured at constant pressure, this is what? Enthalpy, delta H. So dH equals to now Cp dt. Okay, when I say du, it is Cv dt. When I say dH, Cp dt. So this is for 1 mole. For n moles it is Ncv dt. That is also for n moles Ncp dt. So write these two relations. What is this? du equals to Ncv dt and dH equals to Ncp dt. Okay. Read this question once. Read it once fast. 2 moles of an ideal monoatomic gas is allowed to expand adiabatically. So what do we mean by adiabatic? Like isothermal we have studied. Next isochoric we studied. Next isobaric. Similarly we have something called adiabatic. So when I say adiabatic, what is constant here? Q. If this is a system, whatever the heat present in the system cannot be exchanged with the surroundings. So there is no exchange of heat between system and surroundings. Then that process is called constant here. Okay, then change in Q will be, dQ will be 0. For which process it is? Adiabatic. Now what they are asking? Work done they are asking. Okay. So now from first law of thermodynamics, what you can write? du equals to dQ plus dW. From this, which is 0 here? This is 0, then du equals to dW. So now they are asking work done only now. So we can write dW equals to du. So in the previous slide what we have written? du equals to Ncv dt. So what is n value here? How many moles they are saying? So N CV dt. So what is N here? 2. Okay. Now what about CV value they have mentioned? 12 point. This is for the gas. 12.5. Next, what about temperature? Temperature. How much change? dt means T2 minus T1. 300. How much? 100. So adiabatically reversibly from 300 to, see, T1 is how much, ma? Initial temperature is how much? 300. Final temperature is how much? 200. Okay. So now dt means what? T2 minus T1. T2 is how much? 200 minus. So what is the remaining value? So, that is what the that symbol you should not skip. T2 minus T100 here minus 100 Kelvin we got. So this is how many times? This will be 25. 12.5 into 2 means 2500 joules we got, minus this minus as it is. 12.5 2s are 25 into 100 joules minus as it is. Now check the options. There is no option with joules but kilojoules. So what I should do? How can I write? Minus 2.5 into 10 power 3 joules I can write. 10 power 3 means what? 1000. K 22.5 kilojoules. This will be your answer. So which one? So do you got how we are doing this? Yeah. So write one more question now. Four moles of monoatomic ideal gas allowed to expand from 400 to 350 Kelvin, 400 Kelvin to 350 Kelvin. Then the work done by the system is given CV same as this one, CV 12.5. What is the data provided? Once tell me. 4 moles of monoatomic ideal gas expanded from where to where? 400 to 3. That's it. That's it. Answer? Same answer you will get. Okay, I just changed 200 like 100 into 50, that's it. 2 as 4. Okay. Yeah. Again in physics you are going to study about law of equipartition theorem. What is that? Law of equipartition theorem. There you will be discussing about this gamma. Okay, so gamma value is what? What is that? It's a ratio of Cp and Cv. So you can write gamma equals to Cp by Cv. Okay, so that is what here it is mentioned, Cp by Cv equals to gamma, which means Poisson's ratio. So now they will ask you what is the gamma value for monoatomic gas, diatomic gas, polyatomic gas. What I am saying? Monoatomic, diatomic, polyatomic. Okay, so for monoatomic gas, gamma means what? Cp by Cv. See, for a monoatomic gas, monoatomic gas means what? Single, like helium gas, neon gas, like that. It is atomic form now. For them, Cv value equals to 3 by 2 R. How much? 3 by 2 R. Whereas Cp value equals to 5 by 2 R by 3. So upon simplifying these, you will get 1.66. So gamma for monoatomic gas is how much? 1.66. So gamma for diatomic will be 1.4. How much? 1.4. Diatomic gas means what are the examples? Like H2, O2, N2, like that. Okay. Again, same. Cv for diatomic gas is how much? 5 by 2. Then Cp becomes, how these values are coming? See, Cp equals to, Cp minus Cv equals to R. Cp will be now R plus Cv. See, R plus diatomic Cv is how much? 5 by 2. 5 by 2 R. This is how much? 2 R only now. 1 plus 5 by 2 is 7 by 2 R. Okay. So this is what? Cp. Cv is 5 by 2, Cp is 7 by 2. Then the ratio will become 7 by 5 means what is our value? 4.0. Similarly for polyatomic, like triatomic, tetraatomic, like CO2 comes under what? Polyatomic. What is its gamma value, they will ask? 1.33. So what are the values we got? 1.66, 1.4, next 1.33. Remember this. For monoatomic, gamma value is highest. See, what is the joules? You take 8.3 joules, you take 8.314 joule per Kelvin per mole. If they say calories, R is equals to 2 calorie per Kelvin per mole. What is this value? R value, universal gas constant in joules. How much? 314. In calories? 2 calorie per Kelvin per mole. Okay. So you substitute there 5 into 7. Let us put R in calories because 3 options are in calories. Once we'll do with this. 2 into 30. How much it is? 35 into 60. So 0, 0, 3, 18, 21. Got this, how we are doing this? NCP dt is a formula to be used here. So substitute them, you will get the answer. Okay, what is our answer here? Second or first? So that is to be taken calories, same units. Okay. Next, same question I will be asking you. 5 moles of an ideal gas with CV equals to 5 by 2 R. CV equals to 5 by 2 R. Then calculate delta U. Calculate du. So how to do that? Same temperature change, 27 to 87. 27 to 87. How to do this? Tell me. NCV dt. So N is 4, N is 5, 5 by 2 R dt. Dt is how much? Again 60. Substitute, you will get some answer. So du equals to n Cv dt. N is how much? 5. Cv 5 by 2. Next 60, this one. Cv, R na, R value 2 calorie let us take, into 60. 25 into 60. How much it is? Calories. Okay, done. Okay, next one. Once read this. Work done in various thermodynamic process. Like what are thermodynamic processes we discussed? Isothermal, isobaric, isochoric, adiabatic. So first one is isothermal. So what is constant here? So then change in temperature will be 0. So now what happens to first law of thermodynamics? So what becomes 0 here? du equals to 0. du equals to 0. Then what happens this one? dq equals to minus dw. So what it is saying here, the amount minus symbol is there means what? Work done by the system or work done on the system? So now whatever the heat you are supplying to the system is completely utilized to do work by the system. So amount of heat supplied to the system is completely utilized to work done by the system. This is what this symbol says. Okay, the next one, dW. What is the formula, ma? Put pressure into minus PdV. Okay, this is external dV. Okay, external pressure into V, D into V. See, now here we have a piston. What is this? Like it can go up and down freely. Okay, here I have ideal gas. What I have? Ideal gas. So what I am saying, free expansion means this piston can move up and down easily. When I say free expansion, there is no external pressure. What I am saying, external pressure is 0. So free expansion means P external will be 0. So it will easily go upside. So if P external is 0, something 0 into something. So work done in free expansion, how much? 0. Okay, so this free expansion also called as work done in vacuum. What is it? Vacuum. Okay, the next one is isothermal reversible process. What is that process? Reversible process. It means this external pressure and internal pressure. See, expansion compression means what more? This piston either should move upside or downside. If it is moving upside, we can say expansion. Moving downside, compression. See, what is this reversible process means? Yeah, if I slow, like both external internal pressures are almost equal. Now what I am doing, I am slightly increasing the internal pressure. What happens? This piston moves upward or downward? So slight increase in P internal, piston moves upward. So expansion takes place. A slight increase in internal external pressure, piston moves, compression takes place. Okay. So now here what I am saying, dW equals to minus P external dV I am writing. Whenever I say reversible, the external pressure and internal pressure are almost equal. So what is the thing we are taking inside? Ideal gas. So ideal gas equation, what is this pressure formula? We have PV equals to RT now. So RT by V can I write? So wherever I have P, there I can write RT by V dV. So now you have this equation like integral of 1 by V d 1 by x dx. How much? Integral of 1 by x dx, log x or ln x. Ln x or log x you can say. So here also you apply integration on both sides. Isothermal or temperature constant here 1 by V dV. See 1 by x dx means what you can write there? Minus RT ln V can I write? 1 by x dx means what ma? Log x, or ln x also we can say. Okay, so here expansion compression means what happens to the volume? Increasing, decreasing. So it is going from V1 to V2. So this is V1, this is V2. So this is dW. So you put upper limit and lower limit, RT ln V2 by V1. So finally you just remember this work done formula equals to minus 2.303 RT log V2 by V1. So what is the relation between ln and log? ln equals to 2.303 log. 2.303 log. You can write in this way. Okay, wherever I have ln, I have represented like this. Okay, so this is a formula to use where? Work done in isothermal, reversible, expansion or compression. So let me give you one question on this. Work done when 1 mole of ideal gas expanded from 1 liter at 27 degrees Celsius. What is the question they are asking? Once read it. Work done when 1 mole of ideal gas expanded from 1 liter to what they have specified? So it means temperature is constant. If temperature is constant, isothermal process. So how can you calculate work done at isothermal process? This one. So what is the formula to use? dW equals to minus 2.303, okay, R T log V2 by V1. So tell me here 2.303. Let us do this in calories for simplification purpose. 2 calorie per Kelvin per mole into what is the temperature mentioned? But you don't take in 27, convert into kelvins. Degree. How can you convert this? Temperature in Kelvin equals to temperature in degree Celsius plus 3. Okay, so how much temperature they have mentioned here? 27 degrees Celsius plus 273. So 27 degrees Celsius can be written as 300 Kelvin. So take here 300, multiply with log, what is V2? Final volume is how much? 10 by 1. So log 10 is 1. So this value is 1. So finally you have 2.3 into 2 into 300. So how much it is? This is 6, 4 into 3. How much? 8, 1, 12, 13 into 100 we have. So you simply write it as 1380 calories. Okay, everyone got this? Okay, in kilocalorie if they ask, 1.38 kilocalorie. If the same question they are asking in joules, what we need to do? Instead of taking R in 2 calories, you should take 8. Okay, write one question now. Here how much I mentioned? 1 mole. Okay, see if it is 1 mole, you are taking 2.303 RT log V2 by V1 like that. If there is n moles, you should take 2.303 nRT log V2 by V1. If I say some amount, for example N2 gas is given, 14 grams of N2 gas is given, consider it as ideal gas. Now what to do? How many moles it is? 14 grams of N2 means number of moles, find given weight by its gram molar mass. Yeah. Now take the thing, take the question. 56 grams of N2, 56 expands isothermally expands isothermally reversibly from 1 liter to 10 liters, 1 liter to 10 liters at 27 degrees Celsius, at 27 degrees Celsius. Then calculate work done. Then calculate work done. Then calculate work done. In calories you do. So what to do, tell me first. What I am asking you? Work done. What is the formula? 2.3 minus 2.303 RT log V1. Just put and tell me. That's it. Tell me your answer in kilocalories. అందులో nitrogen, I told you. Nitrogen, what is the thing you should consider? Nitrogen atom or nitrogen gas? N2 na? So what is its molecular weight? 28. 56 by, so 2 moles you should take. So 2 into this thing only. So final answer will be this one into 2. Means what is your answer? 2 into 1.38. How much? 6172. 2.76 is your answer? 2.76. Okay. Next. See, one more formula also you can write. Minus 2.303 nRT log V2 by V1. In the place of V2 by V1, we can also write in terms of pressures like P1 by P2. So it becomes like how pressure and volume related, ma? P is inversely proportional to V now. So wherever you have V2, there will write P1 like reverse. So 2.303 nRT log P1 by P2. Okay. So these two formulas you make note of it. Okay. So now see this question. Read it once. What is your answer? Whenever there is free expansion, vacuum, the work done will be 0. Okay, you can remember directly it is 0. Okay, so now one more thing. What is isothermal formula we got? Work done formula. Minus 2.303 nRT, like that we got now. So now first law of thermodynamics, once again you tell me du equals to dw dq. So what is 0 here in isothermal process? Du equals to 0. If that is 0, then dw equals to or dq equals to minus dW. So now the same question they can ask. Instead of asking what is the work done, they may ask what is the heat absorbed or heat released during isothermal process, because same values are like both of them are same values with opposite signs. To the previous question, what is that question you have written? 56 grams of N2 expanded at 27 degrees Celsius isothermally reversibly from 1 to 10 liters. Okay, then what is the heat energy change or what is the heat absorbed by the system? If I ask, heat absorbed by the system, whatever the value you got, that is how much? You tell me. Work done minus 2 point, that is work done. See, this is work done by the system. You got answer as minus 2.76. Again you put this minus plus 2.76 is the amount of heat absorbed during the process. Means the same value with opposite sign. Okay, remember this line. Okay, done up to here. Solve this question once. What is the answer for this? What to calculate, ma? Work done. So now what is the data provided? See, work done they are asking at 300 Kelvin, it means specific temperature, isothermal condition. See, change in volume mentioned from 0.1 liter to 0.1 liter to 0.25 liters. Okay, against a constant external pressure 2 bar. So what is the work done that relates pressure and volume change? Minus P external dV, change in volume. So what is external pressure change? I mean, they have given external pressure how much? 2 bar. Now what about volume change? 2.25 minus final 0.25 minus 0.1, how much? Minus 2 bar into 0.15 liter. So this is how much? Minus 0.30 liter bar. So but answer is not in liter bar, but they have provided, given that 1 liter bar is so minus 30 into 100 bar. So this is how much? How much it is? 30 joules. Okay, so 1 liter bar, how many joules? Remember that value. 1 liter bar is one more relation also you can remember. 1 liter bar 100 joules. 1 liter ATM 101.2 joules. How many joules? 101.3. Okay, 1 liter bar 100 joules. 1 liter ATM okay. Done up to here. See, now enthalpy changes during a reaction. So what I am saying, enthalpy of reaction. See, A2 plus B2 giving rise to AB. 2AB. It means one A2 molecule, one B2 molecule combining to give 2AB. So during this reaction, delta H reaction, I can say, during this reaction, how much energy is changed? They will ask you like this. See, what is forming here? AB are forming, but AA and BB are consumed. It means, can I say deformed? Okay. So here enthalpy of reaction, what I am saying? Or in formation enthalpy, or enthalpy of formation. Enthalpy of formation. So who is forming here? AB is forming. How many moles it is forming? So 2, enthalpy of formation I am indicating with delta HF. Who is forming this one here? AB. Minus, these are forming or deforming? That's why I am using minus symbol. If they are forming, I should use? So that's why it is minus here. Open the bracket. Delta HF of A2 plus delta HF of B2. What are the stoichiometric coefficients? Here. 1. For this one also? 1. That's it. Okay. Now this value they will provide. You substitute the value here and simplify to get the final answer. Okay. Right. Next, let me give you some examples otherwise. Simply what I can say, for a chemical reaction, enthalpy of reaction is equals to enthalpy of products minus enthalpy of reactions. Okay. This is difficult for you. Read this question, one last question, will stop. See what they are saying. The formation enthalpy of CO2, CO and H2 are given respectively. The standard enthalpy of this reaction they are asking. See, this is the reaction mentioned. What is the data given? Formation enthalpy. So who is forming here? CO2 and H2, CO and H2O. So what you can say, then delta H reaction is equals to, what is the data provided for? Enthalpy of formation now. So who is forming here? Write them first. So what is forming here? 1 CO plus 1 H2O. Next, over products over. Next, minus 1 CO2 plus 1 H2. That's it. What is its data provided? For CO, how much now? Minus 110.5. H2O is how much? 1 to third value here. Minus 2 for minus this one. CO2 how much? First value. Minus 393.5. And what about H2 they haven't provided? So the standard enthalpy of any molecule which is in the stable form. Like in the nature how H2 exists? Hydrogen exists as H2 only now, the gaseous form. So its enthalpy, standard enthalpy will be 0. Even if they give O2 also 0. Okay, done. Okay, here you take 0. So simplify this, you will get one of these options. Okay, just simplify this. Simplify this first.